Thank you very much. Nice to see so many of you here. I was a bit afraid it's going to be like 4 polite colleagues and 3 bored people with laptops. My name is Kalle Happonen. I work for CSC. I've been working with our clouds for about 15 years, like our self-hosted clouds. I'm going to have a bit of a rambling talk today. I'm going to touch on stuff like sovereignty, Kubernetes, clouds, and research in general. And because I'm going to talk on the quite high level many times, just as a disclaimer, these are my own thoughts. CSC might have their own, we might have our own company thoughts on this. I don't want to muddy the water, so this is just my own thoughts, but I don't think it's very controversial. To start with, how many of you have heard about CSC? Oh, whoa, that's much more than I thought. I will still do the introduction slide because I had planned it in my timing. So CSC in a nutshell. We are a company, but we are owned by the Ministry of Education, universities, and universities of applied science. Our whole goal is to provide research and data and education services to the academic sector. We're non-profit, we shouldn't make profit. We are measured on how beneficial we are to our owners. We have 2 offices. We have one actually just on the other side of the road. If you have seen the big wooden wedge, we are moving there in a few months. We are now next to that. And then we have our big machines up in Kajaani. It's about 600 kilometers north. We have a big data center, and there are some very big computers there, and some of our admins that we have lured up to the central Finland. When I started about 15 years ago, we were about a bit over 200 persons. Now we are 700 persons, and this is largely due to the digitalization of education and research that has been going on. We have been providing Kubernetes for research since 2018, and that's one of the reasons that I am here today. A brief look into our history, because I actually find this fascinating myself. We are old, like I think we're turned 55 years old as a company. Or we weren't a company in the beginning, but our history reaches that far. We host a lot of stuff like FUNET, which is a networking that connects the universities, and CSC connected Finland to the internet in the late 80s. So we have that milestone. In the late 80s, we also had the Finnish first supercomputer, and we have had tons of them since. And in the 90s, when Linus was working on his Linux, it was uploaded because we served like academia with IT resources. It was uploaded to the CSC and shared from the CSC infra. So I'm quite happy about, we have quite a big footprint in the IT history of Finland, which is, I think, very exciting. From the recent stuff, you may have heard about the Lumi supercomputer. I'll say a few more words about that, but in the early 2020s, we had a huge project with EU Commission, 10 other countries, or 9 other countries and Finland, to build and buy Europe's fastest supercomputer into Kajaani. So when it came there, it was the fastest supercomputer in Europe, and it's still very high on the top right now. And a positive thing is it's actually getting a next chapter, so it's getting a sequel, so we can continue the story of the very big level supercomputing in Finland. Before I go to the more fun technical stuff, I will touch a bit on the high level thing that is affecting a lot of us right now. There on the slide you see a Google trend of the term digital sovereignty. You see it's basically a year old. This means, in my opinion, that it's very feelings-based. It's not very clear. People mean a lot of different things about this. But it is not necessarily a new thing, even if the term is new. For those of you who have been longer in the industry, many of you remember when Yandex came to Finland, like a Russian IT company about 15 years ago? Yeah. They built a data center in Finland, and exactly the same discussions were had then, like what is sovereignty, what can we put there, who can we trust with their data, what are the role of the national actors. And please remember that even in that age, the relationship with Russia was also very, very different than it is now. So this is a long-term topic and not only new. In my opinion, to crystallize what this means, like I think this is a huge gray area. I don't have like very absolute feelings about this. But in general, we have to be able to run our IT without undue influence. Things always influence our IT, like vendors, customers, and all of that, but we should be able to control that. There are technical controls, and there are like contractual controls, but controlling laws and like that is very, very hard from a user perspective. In enterprise environment, I think this would fall quite much within long-term enterprise risk management, but on the national level, I think this is a bit more higher priority. And I think on the flip side of this digital sovereignty thing is that we need to be able to build infrastructures. It's a skill you lose, and if we don't maintain that skill, building them when we need them, it will be very hard. So, how does this touch research? This is usually a very political topic, but actually this is very, very important for research right now and has been for a while, because research is increasingly more politicized. Of course, you can think of these big things like climate change. That is very politicized as research, but it extends to a much, much wider set of research. It's ecology, health, vaccines, economy, racial studies, gender studies. All of these fields are very, very politicized. And this is a problem for research. Research, in my opinion, is the source of the good information we need to solve a lot of the big challenges that face the world now, and we need good and accurate information. So research needs to be able to find the uncomfortable truths and release the uncomfortable truths, even if it's not always desirable for the people who funded the research. And it's not only research, this hits research infrastructures quite hard. I have examples from I have colleagues in Europe. This was directly from the changes in the funding in the US. They shut down a lot of the big data repositories that were used for global research, because research is global. And they had to scramble to get copies of that data into Europe so that we can actually provide research with accurate data and not lose the history of the research. So this is actually this already affects our daily life when we come to research. And that is why this is important. Now you might think it's like, okay, this is what we do now. This is one of our big motivators of what I'm going to show next. Not really, but this does play into what we are doing also. So, for something more fun, IT, computers, this is always much more easy to talk about. To understand CSC, since we had Lumi, the big computers, our research infrastructures are mainly split very roughly into two sets. We had a very big European infrastructure. It is very big. And then we have the national infrastructure that supports the national research. The European infrastructure is interesting in its scale. It's a bit more specialized, and it's newer. So we have some cloud services there. We have object storage, we have Kubernetes, but the scale is, or the maturity of those services is smaller because it's newer and it's more specialized. On the national side, we have to support all kind of research, which also means that the services are much wider, and we have been working with them for 15 years. So the service portfolio is much bigger. So I'm going to touch that today because I think that is more relevant for what we do for the sovereignty part right now. Sorry, just. So this is a very high-level picture of our cloud stack. Now there's a lot of disclaimers here. First of all, this is in no way an exhaustive list. This is things we directly offer internally at CSC, but also to every researcher in Finland. So this is a cloud stack that is a researcher can click, take into use in 10 minutes. We have, of course, a lot of supporting services for our internal stuff that are not here. And we also have a lot of more specific targeted research services for researchers. But these are the so-called building block services that we internally use and customers use to do their own stuff. They're a bit like lower level is low infrastructure level, and then we go up levels. If you quickly go through this, we are very big users of OpenStack. We have an OpenStack for sensitive data. This is mainly genomics, bioimaging, all of this to do for researchers. We have a community cloud, also a general OpenStack infrastructure cloud. We have Allas, object storage, S3, one of, I think, our more important services. And I added also here our high-performance computing, our supercomputers. Roihu is the newest one. It's actually very new. It has an inauguration in 2 days on Friday, so it just installed. I added it here because while we don't always count it as cloud services, high-performance computing and batch computing is becoming so much more important across the whole IT field. So it does tick many of the boxes. Then a bit newer, of course, we have our OKD. I'm going to touch a bit more on that, but we have our Rahti Kubernetes service. We have been running for production-ish in 7 years. We have our Pukki database service available for all the users, and this year we are releasing Satama, which is our container registry service, and Aita, our AI inference service. Now, personally, I am really proud of this stack. I think this is awesome to have a stack like this built on open source. And the things I have seen, people in-house build on this, how fast, or customers build on this, researchers build on this, I think it's super exciting. I am the first one to admit that because this is a glued together open source component, it's not as sleek, it's not as completely polished as many of the commercial solutions, but it gets the job done and it is heavily used. A bit on our scale, because this gives some perspective. We have a big infra change right now. So the numbers are a bit hard to guess, but this is pretty much after our big infra change, excluding our high-performance computing servers, because those are at scale at themselves. So the cloud runs on 700 to 1,000 servers. I think we will stabilize around 700 to 800 after all the upgrades, but then it'll usually slowly grow up. From this is storage and compute. About 35,000 compute cores, 60 petabytes of raw storage, roughly half maybe easily usable, and over 150 GPUs. We have over 5,000 projects on this cloud infra, and 6,500 users, so it's a significant part of the research community in Finland. This means that we are not huge, but we are not tiny either. We are quite large in our infra, and running this infra is, I think it just makes running this infra quite exciting because when you do it at scale, because you have to think about completely new things. A bit more, I will come back to the previous one. A bit on Rahti. So Rahti is our Kubernetes service available for all researchers. We started with OKD 3. The reason we started with OKD in the first place. Like if you remember, 2017 was quite early days of Kubernetes. It was not where it is now, but even then OKD was the only sensible multi-tenant solution that we could find to run this. I'll talk a bit on our approach with open source soon. But we started OKD to have tenant isolation, and we ran the platform for quite a long time. In 2024, we had a relaunch on OKD 4. It took quite a while to build this, mainly because we had to learn of our mistakes before building it. So we did a lot more planning for scale, planning for a lot of users, and benchmarking and testing, and we launched it in 2024. And like normal, we have our like admins here, so they can probably tell you how many environments we have. We have devs, QA, prod, like normal. And about 900 namespaces run on this cluster. Everything from internal production to customer research. 800 cores, right now 40 workers, but this is running on top of our OpenStacks, so it is like auto-scaling up as we need it. And some numbers to compare. LumiK is about 4,000 cores. So the European scale is larger, even though it maybe doesn't have all the same capabilities. We also are a bit late on the GPU availability, but we will have GPU availability in 2026. So this year, when we get our new infra there, we have had GPUs that we could have integrated earlier. But when we do something, we have to consider the community. So it doesn't really help us to give one research project a GPU. We need to make sure that there's a significant amount so that like we can support a large part of the research. Then I'll go back. We are maybe a bit different than many of the companies when we build these services, because our focuses are quite different. First of all, you might see that I spoke a decent amount on digital sovereignty in the beginning, but you see it nowhere on these slides. It's partly on purpose because I think we are mostly talking about generally controlling your environment, controlling stuff, and these other things drive us in the same direction. So first of all, we serve, like as you said, we have 6,000 users. A few years ago, we had 4,000 users like on this. We have a very big user base, and let's say we are quite cost optimized. The state doesn't have infinite money to throw on this, so we try to do this as efficiently as possible. And one of the effects on this is that when we start something new, let's say these are fictional numbers, but the example is real, Pukki database service. When we started, we maybe had 20 users. Completely fine for a start. Then it scales to 200 or 400. When the service scales, we don't get more money to scale this. Like we basically scale this on the same budget, so we have to plan in scaling from the beginning. And this means that we do a lot on open source. Like most of the commercial licensing model don't work for us at all because they scale per users and we have tons of users. Research is generally at a very large scale. So as an example, I think we had some important project and we were thinking, should we support license our Ceph, our storage systems? It turns out for the licensing cost a year, we could hire 30 admins, like 30 admins to support that system. And if I had that money, I would hire like 5 admins, 5 upstream supporters, and like save the rest because those numbers don't work for us. So scaling is important and cost-efficient scaling is important. But also if control over the whole ecosystem is very important for us because if you look at our stack I showed a few slides back, the purpose of this stack is not this stack. The purpose of this stack is to support research. So most of the purpose of this stack is the research services that run on top of this. So we have to actually tailor the whole ecosystem so it supports all the needs we have. Example, big data, like if industry comes with a terabyte research might come with 100 terabytes. So we have to take all this into account. And also we have very many special research cases, like you have sensitive human data. We have to build this into all of our stack so that we can support the research. So we're actually building a cloud ecosystem for research. And ironically, the more and more users I can drive away from this platform, the happier I am, because then I drive them to higher level services that are closer to their needs. So those are our end goals. Another thing that we also plan for is long-term sustainability. If we look at our, I am supporting a project that had like 5 years planning, 15 years data generation, 10 years of data after the project. So these projects don't have very much IT resources, so they cannot handle that many platform infra changes where they come. So we have to take those into account. I'm a bit late on time, so I will go quickly through the maybe core part of this. Kubernetes has been a blessing for us. I very much love that we have it growing in importance. And I think the main thing, this is so good because it's so widely spread. And if you look at the cloud providers, up to now, the highest common denominator for workloads has been a virtual machine. And that is quite low, and that is not very transferable between providers. The highest common denominator for APIs for compute has been nothing. Like, they are all different APIs. So Kubernetes solves these both things very well and in a in a fashion that is very compatible. So it both solves the API, so users can work on a high level, and it solves the workload that they can plan for the high level for their workloads. This again feeds a lot into the sovereignty talk. Like, this makes the transfer of workloads much easier. It doesn't really matter where it runs. And I think this will be more and more and more important for our users. Again, this doesn't mean that I want to import all our users to Kubernetes, but I want to import the services that we build for the users on top of that to make their lives easier. And final things, I think like 3 things for consideration from this talk if you haven't gotten anything else. We have been building this infra for 15 years to get at this stage. Of course, you could get there faster, but we have our own constraints. But building infrastructures takes time. You can get some benefits quite early, but building long-term infrastructures takes some time, and that is something you have to prepare for. In the last few years, it's getting better now. There has been quite a lot of negativity in building your own also. Like no, just buy it. Don't care about building it. And the times I have heard, no, this is not possible. You cannot build this cost efficiently. You should buy it. I assure you, we can build this quite cost efficiently compared to buying. Or you can never run it at high enough quality for it to be useful. It is not actually that hard. It takes some architecture design, and you can do it. I even had once a consultant from a big company. They were consulting us on cloud strategy, and they said, "Oh, I like your stack. It's very nice, but like you need to use public cloud also because you can never do stuff like database as a service locally." And this was while we were building a database as a service offering. So there has been this complete thought in the industry that this is not possible to do yourself, and I will say it is very possible to do yourself. It takes some time, as I said, and the second thing it takes is scale. So I wouldn't do this for 5 servers. You don't need to be nearly our scale for this to be useful. But if you're 10, 50 servers, like something like this is completely possible to build. And it might be worth it. The thing is, it's in the end a business decision, but I don't think there is very much good information for the business decision makers to do these decisions on. And the last thing, Kubernetes, I love it. It's excellent for cross-compatibility. It'll get more and more of our workloads, and it'll be a workhorse at CSC. And I think this will also translate to how Europe does research, because I see more and more research projects consolidating on Kubernetes as their platform instead of something lower than they have previously done. I think that's it.